Hello, welcome to Analog Arts Arbitrary Function Generator tutorial. Please feel free to download the demo application software from analogarts.com to help you follow this tutorial. For this presentation, we use a 150 MHz generator, one of the instruments of SL987. This instrument offers a set of standard signals as well as the ability to edit and generate waveforms. The application window consists of an editor panel, a navigator panel, a standard signal panel, an output panel, and a utility panel. Each individual button in these panels allows the user to perform a unique task. Together, they control the various features of the generator. In order to illustrate these features, we connect the output of the generator to the SL987's oscilloscope channel 1 input using a coax cable. We also connect the external trigger input of the oscilloscope to the sync output of the generator for triggering. The buttons marked with standard and arbitrary in the output panel indicates which mode of operation is being used. It also showed the output signal of the generator. To generate a signal in the standard mode of operation, simply switch on its name in the standard signal panel. For convenience, the corresponding parameters of a function are listed only when it is selected. For example, choosing the square wave from the list makes the duty cycle panel appear. And for a DC signal, only one parameter, the DC level, is listed. To change the unit of a parameter, simply click on it. The parameters of a signal can be changed either by entering the desired value or by the scrolling of the mouse wheel. Switching on a signal with more than one type directs the user to the list of its varieties. Selection of a ramp signal, for example, shows its different variations: triangle, falling ramp, and rising ramp. The button marked back brings back the previous signal list. Switching on the modulated button guides the user to the modulation list. It offers AM, FM, sweep, burst, and digital types of modulation. The AM button opens a window by which the modulating signal can be described. The modulating signal and its parameters can be specified from this menu. If you have already created a custom wave and wish to use it as the modulating signal, select the edited waveforms. The reset button resets the window to its default settings, and the exit button closes the window. To open the window, click on the selected modulation signal. The carrier frequency, the amplitude, and the offset of the output are listed in the standard signal panel. Generating FM signals is very similar to generating AM signals. For FM signals, switch on the FM button and enter your desired output parameters. Sweep signals are also simple to generate. Its corresponding parameters can be specified as in other signals. To make the sweep linear, click on the linear, and for exponential sweep, turn on the exponential button. The direction of the sweep is determined by the button at the right side of the exponential button. When it is labeled up, the direction is from low to high, and when it is labeled DN, the direction is from high to low. The output panel shows the symbol of the generated signal. Clicking on the burst button opens a window called Burst Carrier Signal. It enables the user to select a burst signal and specify its parameters. The number of cycles in the output is a function of burst rate and the frequency of the burst signal. If a burst count number exceeds the allowable limit, the burst count text box would highlight this condition in red. Pressing the Enter key in this situation notifies the user about the burst count allowable range. In the default mode, when the sample button is on, burst signals are generated continuously according to the burst rate value. To have a gated signal, switch on the gated option. In this mode, connect the gating signal to the sync signal of the generator. To output an individual burst of a signal, first choose the signal mode and then click on the Send Burst button to send it. Switching on digital features the ASK, FSK, and PSK types of shift keying modulation. Respectively, they represent digital data as variations in the amplitude, the frequency, or the phase of a carrier wave. Therefore, we have to specify the modulating signal and its parameters both for the space 0 and for mark 1 to represent zeros and ones. Be sure the proper button is on when specifying the modulating signal parameters and also when the signal is applied. To have a gated signal, turn on the gated button and also connect the sync BNC of the generator to the gating signal. The special signal category offers pulse, sync, rising exponent, falling exponent, and cardiac signals. To generate each signal, switch it on and specify your desired parameters. For arbitrary signals, first we have to edit the signals. The editor panel offers four different types of signal editing. They are manual, pen, line, and insert. Each mode is activated by its corresponding button. In the manual mode, the user can edit the signal point by point. To do this, simply enter the memory location and the output voltage. Then, to apply the values, press the Enter key. This is a suitable method to generate precise signals. To output the edited signal, turn on the arbitrary button in the output panel and then click on Apply the edited wave button. For convenience, the horizontal and vertical coordinates of the mouse is always displayed near its position. Pen editing, as its name would suggest, makes the mouse work like a pen while its left button is held down. This is a convenient way to create waves. In the line editing mode, each left click of the mouse marks the beginning of a new line. Notice that in this mode, the edited section is in yellow color. The right click of the mouse ends the editing. Clicking the Insert button on opens the Insert Signal Editor, which allows the user to describe the insert signal and also state the insert position. In the parameter list, the insert point is the memory location in which the first point of the signal would be placed, and the insert span is the amount of allocated memory for the signal. The cycles parameter is the number of signal cycles in the allocated memory. Once memory specifications are entered, select the type of the signal to be inserted and specify its parameters. Then, to apply the edited memory, click on the Apply button. There are also copy, cut, and paste actions. To select a segment of the signal for cutting or copying, drag the mouse on the intended segment. Then, to copy or to cut the segment, right-click the mouse to open the copy menu and choose the desired actions from the menu. A cut or a copy section can be inserted into the signal by the paste option. A left click on the option pastes the segment at the location of the mouse. This location is specified in the Paste Initial Point text box, which appears on the screen as soon as the mouse is over the Paste option. This text box enables the user to modify the insert position. Clicking on the Clear button clears the editor screen. This results in a 0-volt signal. The undo and the redo buttons do exactly what their name would suggest. They bring the editor to the previous and the next 100 states. The zoom in button places a rectangular zoom area on the screen. The zoom area, which is highlighted in pink, can be modified as needed. Each side of the rectangle can be dragged in both directions by the mouse. Also, this area can be moved. To move it, left click inside the area, hold the left button down, and then move it to the intended position. Once the zoom area is defined, click on the zoom in to expand it. The zoom out button makes the screen show a bigger portion of the signal, almost twice bigger. The vertical and horizontal zoom buttons, marked by two parallel vertical and horizontal bars, offer vertical and horizontal zooming. Clicking these two buttons places a corresponding pink area on the screen, which can be dragged by the mouse and expanded by pressing the zoom in button. To have the full view of the signal, click on the Home button. To center the screen with respect to a memory location, simply enter the memory location in the center lime-colored text box in the bottom of the editor screen. The scroll button in the on condition enables dragging the screen by the mouse. The Navigator panel also offers another method to scroll the editing window. To do this, grab the orange box in the panel and drag it by the mouse. This generator features windowing, filtering, and math signal processing. For windowing, click on the DSP button first and in the DSP menu select windowing. Then choose your desired function from the windowing menu. The filtering option opens the filter selection window that allows the user to select the type of the filter and specify its parameters. Mathematics operation on waveforms can be performed in the Math Operation window. To open the window, select the Math option in the DSP menu. The text boxes, a starting memory point and ending memory point in this window specify the memory segment where the operation is performed on. Notice that the segment is highlighted in white color in the original signal plot. The menu labeled Math Operation opens the list which features a number of mathematics operations. For add, subtract, and multiply, the operating waveform must be created first. The Create Waveform button opens the Insert Signal Editor window, which can be used to define the operating signal. After the operating signal is created, to view the resulting waveform, click on the Preview button. To multiply the waveform by a factor, select Gain option from the Math menu, then enter the gain factor in its text box. The Absolute option produces the absolute value of the signal at the output. To limit the output, select the Clip option, then enter the high and low clip values in the appropriate text boxes. To invert the signal, select the Invert option. When the mirror option is selected, the resulting waveform would be a mirrored version of the signal. The signal can be resized both vertically and horizontally. When the resize option is selected, the X span and the Y span text boxes allow the user to set the resizing area. Resizing maps the signal defined by the memory points into this area. Notice that the resulting waveform is centered around the middle of the memory. The expand to fit operation expands the signal to fit into the entire memory. The apply button applies the operation to the edited signal each time it is clicked. To close the math operation window, click on the exit button. In the editor panel, clicking on the hardware button opens a menu which allows the user to set the sampling rate, the memory size, and to enable or disable the reconstruction filter. To change the sampling rate, select the sampling rate and then enter the new sampling rate in the corresponding text box. The new sampling rate is applied when the Enter key is pressed. The memory size can be changed in a similar manner. For this, select the memory option, enter the size, and then press the Enter key. Clicking the Filter Disabled option disables the filter, while the Filter Enabled enables it. A checkmark symbol shows the selected option. The edited waves can be saved at any time. The Save Wave and the Recall Wave buttons facilitate the process. The utility panel on the top of the screen assists the user to perform a number of tasks. The Reset button brings the generator to its default condition. The arbitrary generator setting can be saved in a text file. To do this, simply click on the Save Settings button. The Recall Settings button allows the user to load any desired settings. In addition to the settings, the user can save the generator plot and recall it at any time. The plot can be saved in a variety of formats. The Calibrate button starts the set calibration process of the generator. This process usually takes about 10 seconds to complete. Clicking the Print button sends the generator plot to a printer selected by the user. The Help button guides the user to an online analog art information site that hosts a collection of user manuals, specifications, and useful application documentation and videos. We hope you have enjoyed this presentation. For additional information, please send an email to info@analogarts.com.